Welcome and thank you for joining. Let's take a look at another cool, very neat equation. So this time we have 5 plus 2 root 6 to the power of x plus 5 minus 2 root 6 power x equals 2 root 3. So quite interesting. We have the variable x appearing in two terms in this equation. Here, this is a constant. Now, the problem is, though, that we cannot really find a connection between these two, or can we? So as you can see, these two bases, they do have same terms, but there is a minus and a plus in here. So that means that they cannot be combined or merged together. So we got to be creative this time. And this is what this example is teaching us: creativity, imagination. And this is what math teaches us: imagination beyond of what we see. So we're going to try different ways and we'll see what works, what doesn't work, go back and forth. So let's get started. So when I see that I have two different bases that are somewhat connected, you see that this is kind of the sum difference of squares, right? So this sum and this difference multiplied will give difference of squares. Now I'm thinking, so that was my first thought when I was looking at it. I thought, what if I multiplied by the conjugate of this? So if you have the plus and the minus. So that won't really solve my problem, because if I multiply by the conjugate, I'm just going to get just different exponents, and I'm going to have even more variables on the other side. So I gave up that idea. So I thought, what if I multiplied every term in this equation by this very first term? So let's see what happens. I'm going to make that very first term pink: 5 plus 2 root 6 to the power of x. And I will allow this term to multiply every term in this equation. So I'm going to copy it so it's faster for you while watching it. And this will multiply 5 plus 2 root 6 to the power of x, and then plus. So let's copy again and paste. So 5 plus 2 root 6 to the power of x will multiply 5 minus 2 root 6 to the power of x equals, so one more time, we have 5 plus 2 root 6 to the power of x multiplying 2 times root 3. Let's see what we have cooked here. So there is not much that we can do in here besides the fact that we have the same base, we can combine them, and the power has become x plus x, which equals 2x. So I'm going to rewrite this first term as 5 plus 2 root 6 to the power of 2x. I'm not afraid of powers of 2x. I sense, every time I see the 2 in front of x, I sense a quadratic exponential equation. Now the base is a little bit awkward, but I won't let that bother me. Okay, so I'm just going to focus on the fact that this is an exponential equation, and I just found out that it can be quadratic. Now, let's take a look at the second term. So as you can see here, we have the same power, and I'm going to bring here one of the exponent properties. So if you have a to the power of x and you multiply it by b to the power of x, since the powers are the same, then you can say that's ab to the power of x. And it's actually easier if you can say it this way: a times b to the power of x, power applies to both. So that's how you get a to the x, b to the x. So you probably see the idea where I'm getting into. So I would bring the power of x out of the product, and this product will come inside here. And I really, really like how this is going to work out, because look at this. We have two conjugates, one with the sum, one with a minus. You see, they're conjugates that are multiplying each other. So that's good news. So 5 minus 2 root 6. And when I say good news, is not that I know and I see the solution right away, but I see that something is transforming, that something is working, right? So look at each and every step with curiosity instead of anxiety, or try to. I know it's not easy, but with practice we'll become more confident, because we learn more and we think more, we imagine more, and we kind of know what we're doing and establish this faith in our intuition. So last term here, I'm going to bring the constant coefficient to the front because that's tradition. Let's admit it. And then to the power of x. So the very first term, since it is quadratic, I'm going to make a statement that this is a quadratic and it's loud and clear, and 5 plus 2 to the root 6 to the power of x is squared in here. So I have this good looking base in here to the power of 2. And then plus, now this is the exciting part. So when you multiply these two conjugates, then this is difference of squares, right? So that would equal, and I'm taking the steps slowly, 5 squared minus 2 root 6 squared, right? And all of it will be to the power of x equals 2 root 3. And then times 5 plus 2 root 6x. All right. So again, 5 plus 2 root 6 to the power of x squared. And then plus, and now this is the exciting part. 5 squared, that's 25, minus power of 2 applies to number 2 and root 6. Now 2 squared is 4. Root 6 squared is 6. So 25 minus 4 times 6 is 25 minus 24. And 25 minus 24, excuse me, but is simply 1. So 1 to the power of x. And on the other side, I have one term. I'm going to bring it to the left because I sense that here we're going to get a quadratic exponential equation. So we have 5 plus 2 root 6 to the power of x. And one thing that I like now is that, yes, I do have the exponent x in two exponential terms, but at least I know that their bases are the same. So that's a gain, all right? And look at this little innocent term in here. So I wanted to think, what is number 1 to the power of x equal to? So no matter what the values become in the exponent, when the base is 1, then the term will have a value of 1. So here we go, 5 plus 2 root 6 to the power of x, all of it squared, minus 2 root 3, 5 plus 2 root 6 to the power of x, and then 1 to the power of x is 1 equals 0, equals nothing. Do you see the quadratic equation now? So it's going to look even better when we replace this good-looking base in here by some coefficient a, by some number a. So a is coming here, a is coming here, and this equation will turn into a squared minus 2 root 3a plus 1 equals 0. Now, obviously, it's not a traditional classic quadratic equation. It has, radical coefficients, but it's not unsolvable. We can easily use a quadratic formula. So we're going to say that the coefficient a, or the unknown a we're solving for, would be equal to negative coefficient b, so negative 2 root 3, plus or minus square root of, remember we have the discriminant, so that would be negative 2 root 3 squared minus 4 times 1 over 2 times 1. So a equals 2 root 3 plus or minus, so let's take a look at this, power of 2, 4, root 3 squared 3, 4 times 3, 12, and 12 minus 4 is equal to 8. So we have the square root of 8 over 2. Keep simplifying, so we have 2 root 3 plus or minus 2 root 2 over 2. So notice that 2 is a common factor in the numerator, which means that we can take it out, and that would be root 3 plus minus root 2 divided by 2. So in other words, we obtain the value of a equal to 3 plus minus root 3 plus minus root 2. So again, we have to solve for x. And that means we have to bring a in, so or 5 plus 2 root 6 in. And we'll say that 5 plus 2 root 6 to the power of x equals root 3 plus root 2, or 5 plus 2 root 6 to the power of x equals root 3 minus root 2. So we'll say that x equals the log with base 5 plus 2 root 6 of number root 3 plus root 2, or x equals log with base 5 plus 2 root 6 of root 3 minus root of 2. So this is the solution in logarithmic form. And the next thing that we want to do is try to simplify to the best possible. So one way of doing this is by simply writing it with a change of base formula. So log of root 3 plus root 2 over log of 5 plus 2 root of 6, and log of root 3 minus root 2 over log of 5, plus 2 root 6. And voila, this is a solution to this beautiful looking equation. Now, last things last, you need to check the solutions, especially if you have worked with logarithmic terms. So we want to make sure that the x values that we obtain are working for each logarithmic term, but we don't have logarithmic terms in here. So the only last thing we need to check for is if these logarithmic terms exist before we state them as solutions. So the idea is that the expression inside log has to be positive, cannot be 0. Now this is positive, so we're good here, we're good here. That means that these will be the final answers. Again, thank you for learning with me. Bye for now.